In this video, we will learn about geometry of complex numbers. And we will do that using a problem from ISI Entrance 2020. It's problem number 10 from the objective section. I have discussed the geometry of complex numbers several times in other videos in this channel and also in the Chinta Math Olympiad program and ISI CMI entrance programs in the live classes. I will also do that today a little bit. So let me first tell you the problem. Suppose this is the complex plane or the argand plane, or if you wish it's just the xy plane. This is the point 0, 0, the origin. And I'll draw two circles. One of them is of radius 2 and the other one, let me draw that in blue, it's of radius 3. Okay, so red circle has radius 2 and the blue circle has radius 3. Now we choose 2 points Z and W. Z is on the red circle and the W is on the blue circle. It's given that this angle is 60 degrees. This angle is 60 degrees. So probably you know this, that a complex number can be regarded as a point on the xy plane or the argand plane. If you have studied complex numbers in school, you know that it is usually written like this, a plus ib. But we can also think of it as a point in the plane a comma b. So it is a normal coordinate of a point in the xy plane. So this is the information that's given to us. Now we want to find out absolute value of z plus w divided by absolute value of z minus w. This is the question. What is the value of the absolute value of z plus w divided by the absolute value of z minus w? One way to solve this problem is to think about rotation and spiral similarity. What we will do is we will rotate this point OZ by 60 degree in the clockwise direction, counterclockwise direction, and also expand this length of OZ 3 by 2 times. So let me write that. Expand OZ, the length of OZ, by 3 by 2, because this is the radius is 2, this one has the radius 3. So if you multiply the length of OZ by 3 by 2, then you will actually get the length of OW. To get the length of OW, and then you also rotate this by 60 degree counterclockwise. Now you have to be a little bit careful. The problem doesn't say that whether you have to go counterclockwise or you have to go clockwise, but it will turn out that both of them will give the same result as far as this quantity is concerned. I will just work on the counterclockwise direction and you can do the clockwise direction on your own. So if you know the connection between complex multiplication and rotation, it's a very important connection. You should definitely learn about it. You can check out some videos that we have posted before. I have put the links in the description. then you will know that this z times 3 by 2 comma 60 degree will be w. What it means is that if you multiply by this polar coordinate 3 by 2 comma 60 degree, if you multiply by this polar coordinate, complex multiply by this polar coordinate, the complex number z, you will get w, because that's exactly what complex multiplication is. It would expand the length of OZ by 3 by 2 times, and it will rotate the complex number z by 60 degree about the origin. So you get this expression for w. Now you can convert this particular thing into Cartesian coordinate or the normal complex number form. This will be simply 3 by 2 cosine of 60 degree plus I times 3 by 2 sine of 60 degree, and you multiply that by z. That is exactly what w is. Now the rest of the computation is really simple. Z plus w is simply z plus z times 3 by 2 comma 60 degree, and z minus w is z minus z times 3 by 2 comma 60 degree. You want the absolute value of it. You can pull out the z. You can pull out the z. So if you do that, you will get 1 plus 3 by 2 comma 60 degree divided by 1 minus 3 by 2 comma 60 degree. Of course, you have to convert this polar coordinate into the Cartesian coordinate and then do the remaining computation. So what do you get? Well, cosine of 60 degree is 1/2 and sine of 60 degree is root 3 by 2. So now let me do the final computation. In the left hand side, you have 1 plus 3 by 2 times 1/2 plus I times 3 by 2 times root 3 by 2. This is the numerator. This is the numerator. And the denominator is 1 minus 3 by 2 times 1/2 minus I times 3 by 2 times root 3 by 2. Take the absolute value of both pieces and you get the final result. So you can do the computation. This is quite simple from here. If you do simplify, a plus ib's absolute value is square root of a square plus b square. So why don't you tell me the final answer in the comment section? It's very important that you understand complex multiplication as rotation and homothety, or in together we say it's spiral similarity. That's a key idea that is used over and over again in geometry problems related to complex numbers. So notice how I multiplied to z 3 by 2 comma 60 degree, because I knew that I would want to expand OZ 3 by 2 times to get the length of OW and then rotate OZ by 60 degree. And the content of complex multiplication is exactly this. It rotates and it dilates. It rotates and it dilates. It's a very important concept. I hope you would look into other videos to understand it if you don't know it already. Thank you for watching this video. I will come back to other videos shortly.